Welcome to VS channel. In this video we will see the discussion on microprocessor 8086 architecture. Before going to start our discussion on this architecture, first we can see what is microprocessor. Microprocessor is an integrated circuit that contains all functions of central processing unit of a computer. Another way, the microprocessor is an integrated circuit which incorporates core functions of the computer's central processing unit. It is a programmable multi-purpose silicon chip, clock driven, register based. It accepts the input data in a form of binary and provides output after processing it as per the instruction stored in the program. So microprocessor is unable to perform any operation without program. If you want to execute the program, definitely the program should be stored in the memory. Here the microprocessor does not have on-chip memory. That means it does not having the memory inside of the integrated circuit. We use the memory unit, external part of microprocessor, and this microprocessor is have a chance to invented when the integrated circuit is entered into the generation of very large scale integration. With this technology, we have a chance to cooperate 20,000 to 1 lakh transistors in single IC. So because of this, we have a chance to implement the microprocessor in a single silicon chip. So coming to the advantage of the microprocessor is available with a low cost after design this in a integrated circuit. So by having this particular technology, so we have a chance to design this with a very less amount of size, and the speed of this also increases, and which is used in the different components, and which is used a less amount of power consumption. Why? Because the integrated circuits are operates with a plus or minus 5 volts, whereas computer is operates with a normal AC voltage. That's why after inventing this microprocessor, we have a chance to operate this microprocessor with a battery. For that reason, we have a chance to use this device, and we have a chance to carry this device very easily, and it does not release a more amount of heat. That means it releases less amount of heat, and which is more trustable device. Why? Because which can provide high accuracy and provide a stable outputs. Then coming to this 8086 microprocessor, the 8086 microprocessor invented by the Intel Corporation Limited in the year 1978, and this microprocessor is a 16-bit microprocessor, which is having more advantage when we compare to the 8085, which is available in 40-pin IC package, that is dual line package. That means the pins are having in both sides of the integrated circuit. Here we are having 3 versions. The 3 versions are operated with the 3 different operating frequencies. The first is 8086, the basic version, which is operates with the 5 MHz of frequency. 80861, which is operates with the 10 MHz of frequency. 80862, which is operates with the 8 MHz of frequency. It consists of 29,000 of transistors, and it is having 16-bit data bus. Because of this, the microprocessor 8086 can handle 8-bit data or 16-bit data at a time, and which is having 20 address lines. Because of these 20 address lines, the microprocessor is capable of addressing up to 1 megabyte of memory, and the 8085 does not have the instruction for multiplication and division, but here in 8086 we have instructions for multiplication and division. And this 8086 is having 6-byte instruction queue. This queue operates according to the principle of first in first out. The function of this instruction queue is which can load free-fetched instructions. For that reason, we have a chance to implement pipelining processor. And here, which is having 16-bit ALU, and the memory is divided into 16 logical segments, where these 16 logical segments divided equally with the 4 different segments. That means we have 4 segments: code segment, data segment, extra segment, stack segment. These all segments are used these memory segments equally, and it is having 4 general purpose registers which is named as AX, BX, CX, DX. The general purpose registers means which stores data and address, and which is having 4 segment registers. The 4 segment registers CS, DS, ES, SS, and which is having 3 pointers: stack pointer, instruction pointer, base pointer, having 2 index registers: source index and destination index register, and having 2 operating modes. The 2 operating modes are maximum mode and minimum mode. In minimum mode, we have a chance to perform functions of any function using 8086 only. In maximum mode, we have a chance to perform functions using microprocessor and other coprocessors. And coming to architecture of 8086, this is the block diagram or architecture or functional diagram of 8086. And this 8086 architecture is divided into 2 units, that is bus interfacing unit and execution unit. Bus interfacing unit manages data, address and control buses and fetches the sequenced instructions from the memory. And we have a chance to find physical address of that location in the memory where instructions are stored, and manages 6 bytes free-fetched queue, where with this we have a chance to implement pipelining instructions are stored. And so this part represents bus interfacing unit. And coming to the execution unit, the execution unit extracts the instruction from top of the queue in the bus interfacing unit, and which decodes them, generates the operands if it necessary, passes them to bus interfacing unit, and according to the instruction which give the control signals to the other peripheral devices and components that are present in the microprocessor. And this is the execution unit. Now we can see each and every part of 8086 individually. First we can see the segment registers. See here in the block diagram, the segment registers are marked with a red rectangular shape. And coming to the segment registers are system-bit registers, which is stores always the base address of the respected segments. That means the code segment register is system-bit register which holds higher system-bit base address of the instruction or program stored in the code segment. Means that the physical address size is 20-bit. We don't have 20-bit register. For that reason, among this 20-bit, the system-bit address is only stored in the register. For that reason, we can select higher system-bit addresses only. And coming to a stack segment, the stack segment also system-bit register which holds higher system-bit address of base address of the stack segment. So in the stack segment, we use base pointer or stack pointer to point the offset address of stack segment. Whereas in code segment, the instruction pointer is used for storing of offset address of the code segment. Coming to data segment, it is also system-bit register which holds the base address of data segment. and the data segment is used for storing of data. And here we use source index register as a offset register of this particular segment. Coming to extra segment, the extra segment register also system bit register which contains higher system bit base address of the extra segment. The extra segment is used for storing the extra data. So, here we use destination index as a offset register in the extra segment, and now we can see the instruction queue. Here we are having 6 bytes instruction queue. So, this particular instruction queue is operates according to the principle of FIFO, first in first out. So, which is loads with a prefetched instruction, that means before instruction the 6 bytes instruction queue are loaded into instruction queue. With this microprocessor having a chance to execute the program according to the pipelining process. When the program is executed according to the pipelining process, the speed of execution or performance of this microprocessor will increases when we come into the normal execution process, and because of this reason, because of this instruction queue, it get chance to have a cache memory in microprocessor. The first microprocessor that is having cache memory is 8086. The next is address conversion mechanism. The need of address conversion mechanism is the physical memory size is 20 bit, but whereas the registers in 8086 contains only 16 bit address. Because of the reason we need to convert 16 bit address into 20 bit address. So, here by using of base or segment registers and offset registers, we can calculate the physical address. Base address means that is a starting address of the segment. Offset address means that is a displacement from the base address. Here we see the formula, that is a physical address that is equivalent to segment address into 10h plus offset address. 10h means here 10 is a hexadecimal number. So, we use to calculate the physical address of code segment, we use code segment and instruction pointer. Now, we can see the pointer and index registers. So, here we have instruction pointer that present in bus interfacing unit, and stack pointer, base pointer, source index, destination index. These are present in execution unit. Now, we can see in detail the instruction pointer. The instruction pointer is the one which can calculates next instruction address, which is system bit register. In 8085 we have program counter to calculate the next instruction address, but here in 8086 we have instruction queue that is calculates the next instruction address. So, by executing the program, this instruction pointer is increments, by incrementing it calculates the next instruction address. So, this instruction pointer is points the offset address in the code segment. Coming to stack pointer is a system bit address which points always top of the stack segment address. To calculate the current address that we are having in stack segment, we use stack pointer and stack segment register. Coming to base pointer is system bit register which points recent memory location in the stack segment. The base pointer is usually used for base index and register indirect addressing modes. Coming to source index register is a system bit register where source index register is points a recent memory location in the data memory segment. That content by using source index and destination index register, we use to compute the memory address of data memory segment. Coming to destination index, the destination index register is system bit register which is points the memory location in the extra data memory segment. So here with a content of destination index register and extra segment, we can calculate the address of extra segment. Coming to general purpose registers. So here we have general purpose registers or four. The four general purpose registers are AX, BX, CX, DX. So AX is a 16-bit register which is divided into two 8-bit registers, where AL is the lower byte of AX register, AH is the higher byte of AX register. The special function of AX register is used as an accumulator. That means it can store the results of multiplication and division. We use AX as a default destination operand when we are performing multiplication and division. Coming to base register, that is BX register, it is also divided into two 8-bit registers, where BL is the lower byte of BX register, BH is the higher byte of BX register. The special function of base BX register is a base index register. We are already having source index register and destination index register. Suppose if any function is required, 3 index registers, where we can use BX as a third index register. The first priority for source index register. Next we can use destination index register. If any need is there for third index register, where we use BX as a third index register. And coming to CX register, the CX register also system-bit register, which is divided into two 8-bit registers, that is CL lower byte of CX register, CH higher byte of CX register. The special function of CX register is we can use as a counter. That means we use for counting purpose, or when we repeat the loop number of times, where the number of repetitions can represented in the CX register. We use this for loop operation and shift and rotate operations, string manipulation operations. And coming to DX, DX is the data register. It is also system-bit register, which is divided into two 8-bit registers. DL is the lower byte of DX register, DH is the higher byte of DX register. The special function of this DX register is which is act as a extension of the accumulator. That means whatever the data is extended from the accumulator, that is present in the DX. So which is happens when we go for multiplication and division operations. And now we can see ALU. ALU means arithmetic logical unit. Here in microprocessor 8086, the ALU size is system bit ALU, which can perform arithmetic operations. Under arithmetic operations, it performs addition, subtraction, multiplication, division, increment and decrement. Under logical operations, it performs AND, OR, NOT and XOR operation. By having the system bit ALU, here we have a chance to perform either 8-bit operation or system bit operations. Coming to control unit. The control unit is one which converts assembly language instructions into machine understandable level. Why? Because the microprocessor or computers does not understand any language, which understands only machine level language, that is ones and zeros only. For that reason, here the program that we write in microprocessor, that should be converted into ones and zeros. For that purpose, we use the control unit. This control unit converts the assembly language into ones and zeros, that is understood by the microprocessor. According to that particular information, it generates operands and control signals. According to the requirement of the operation, this control signals is sent to the all other components that are present in 8086. This control units take the instruction from the instruction queue. Next is flag register. The flag register, here we are having system bit flag register. This flag register provides the information about the status of the results. So here this flag register is having system bit register, and it is having 6 conditional flags, 3 control flags. So, this is the structure of flag register. The 0th bit is a carry, second bit is a parity, fourth bit is a auxiliary carry, sixth is a 0 flag, 7 is a sign flag, 8th is a trap flag, 9th is a interrupt flag, 10th is a direction flag, 11 is a overflow flag. Here we have X. The X is represents unused bit. So, which is unused here in the 8086. And coming to the conditional flags, these conditional flags are generated by performing arithmetic operations and logical operations. Then carry flag. The carry flag means which is represents the carry information. This carry is occurred by performing of arithmetic operations. Whenever we are performing the arithmetic operations, there is a chance of occurring of extra bit. That extra bit is represented as carry. If it is 1 means carry is generated, if it is 0 means carry is not generated. Now coming to the parity flag, the parity flag is represents number of ones in a results. So, if number of ones are even, this bit is becomes 1. If number of bits are odd, then this bit is becomes 0. Coming to the auxiliary carry is a 1, which is represents the carry that is generated by adding the lower nibble of data. Nibble means 4 bit of data. And 0 flag is represents the result is 0 or not. If it is 0, that is 0, the result is non-zero. If it is 1, the result is 0. Sign flag, the sign flag is represent the information about the sign of the results. If it is 1 means it is a negative number, that is a negative sign. If it is 0 means it is a positive number, that is positive sign. Overflow flag, the overflow flag is represents occurring of overflow when we are performing signed operations. So, that means the allotted memory is not sufficient, then there is a chance of overflow. That overflow is represented by this overflow flag. If it is 1, overflow is occurred. If it is 0, overflow is not occurs. And coming to the control flags, we have 3 control flag here. This control flag controls the operations of the processor. Then coming to this, here we have trap flag. Trap flag is the one which is used to verify the program. By using this, we have a chance to execute the program instruction by instruction. That means single instruction is executed and it provides the results and it can wait for next command. And if your command is given, again the next instruction is executed and provide the results, and again it wait for the command. Like this the program is executed. If it is 0 means normal execution, that means entire program is executed and provide the results. The next is interrupt flag. The interrupt flag is one which is allows the maskable interrupts or disallows the maskable interrupts. If it is 1 means it allows the maskable interrupts, if it is 0 means it does not allow the maskable interrupts. The next is direction flag. Direction flag is used to provide the direction of utilization of the memory. Normally we use the memory in auto incrementing nature. That means if a memory is 2000, next memory becomes 2001, next memory becomes 2002. This is the normal nature. So, if direction flag is 0, we can use in auto incrementing mode. If direction flag is 1, then we use auto decrementing mode. I think this video provides the clear information about 8086. If you are feel you get entire information about 8086, then please provide your interest or your satisfaction by giving the like and comment. Please share this video to your friends, and if you not subscribed my channel up to now, please subscribe my channel, that is VS channel, and click on bell icon. Thank you for watching this. Thank you.